We're live. Friends, welcome to ISWA and ISWA's partnership, where we are presenting some of the best minds in waste management to people who are looking for solutions around the world. We've started this partnership early this year, this is the fifth webinar as part of this partnership, and we have one more webinar coming up this year. So please check our website and ISWA's website to know when the next webinar is, and then subscribe to it. My name is Ranjit Anepu. I'm a co-founder of BeWasteWise and international waste management consultant. And throughout my work around the world, I've seen that many people are looking for solutions to waste management. There are really millions of people looking for solutions. And most of these solutions are available in PDFs, really long PDFs, or in international conferences, which are not always accessible to everyone. And so our mission from the very beginning has been to connect people who are looking for solutions with those who can provide those solutions. And as part of that, we've helped the Asian Development Bank get their knowledge out to their audience. We've helped Waste Aid UK and MWH Global. And now we're working with the ISWA, with International Solid Waste Association, to present Bernd, Jürgen, and Christian to you today. So with that, let me get Bernd in first. But before he starts, remember that each one of the presentations will be 15 minutes long, and you can ask questions at any point during the presentation. So if you have a question for Bernd, then use the live chat window below the video stream and mention Bernd's name and then ask the question. Please don't wait until the last minute to ask questions, because once we get there, there'll be too many questions that we can't answer at once. So try to ask the questions as soon as possible, and follow us on social media, and follow ISWA on social media so that you're aware of all the upcoming events. So with that, Bernd, please take the screen.
Okay. So you see the full screen?
No, we don't have the full screen yet.
You have it?
No. So you'll have to share the screen.
Share this.
In just 1 minute, and the presentation will start in 1 minute. All right.
So you have it?
That's good. Yeah.
Okay, fine. So good afternoon to everybody. My name is Bernd Leowald. I'm working at the Stadtreinigung Hamburg here in Germany. I'm responsible in this municipal waste management company for waste collection, road cleaning, and winter service in the western part of Hamburg, and for bulky waste collection and container service in the whole area of the city. What I'm going to do now, together with my colleagues, is to give you an overview over the European waste collection system. I will start with a truck-based collection system, so we use it in our company. I'm talking about rear side front loaders and the lifting devices for the systems. First of all, I like to show you the most common waste collection vehicle in Europe, our what we call working horse, our standard rear loader. In the back of the body here is a hydraulic-driven compactor installed. The compactor is able to compact the waste with a ratio up to 4:1. That means that you can fill in a 20 cubic meter body up to 80 cubic meters of waste. In combination with a low or high level lifting device, I'll show you later, you can empty all European standard bins up to 1,100 liters, even with bulky waste. Christian will show you the bin system later on. To empty the body, you have to open the bag and empty it by using the pressing shield, driven by a large hydraulic cylinder. I will show you now the most important advantage of the system from a logistic point of view. You know, the system has a high compaction rate, up to 4:1. It is not so expensive, and for most of all, it's suitable for all fractions. You can collect the residual waste, the bio waste, the paper and plastics, and also some other fractions you want to collect. It is even suitable for bulky waste in combination with no lifting device or in combination with a low-level lifter. I'll show you later. The disadvantage of the system is you have a lot of hydraulic-driven moving parts in the rear part of the body. There are a lot of hidden corners you have to clean, so the effort for cleaning is very high. You have a high effort for maintenance, and you have a high construction inside the compactor that causes less payload. There is a special rear loader in Germany available, the rotating drum system. We have only one manufacturer for that in Europe because the system is patented. The body is driven by a hydraulic engine. It is rotating clockwise and moves the waste using inner guiding rails forward. When the drum gets filled up, the waste comes in contact with the pressing cone at the back of the body. That causes the compaction of the waste. The body is excellent for the collection of bio-waste because the rotation of the drum, you have no problem with water and other liquids. The back of the body is easy to seal. Nothing is coming out. To empty the body, you have to open the back and turn the body counterclockwise. The advantages of the rotating drum is a lightweight and therefore a high payload. It is excellent for residual and bio-waste. Only the drum is moving, no other moving parts are in there. You have a lower maintenance cost, it's easy to clean, and it's easy to operate. The disadvantages are a little bit the price. It is a little bit more expensive. You have a lower compaction rate, up to 3:1. It is not suitable for paper collection and not suitable for packaging collection. One of the most important advantages of this one is in combination with a steered rear axle, the vehicle is easy to operate in narrow areas, as you see it on the picture. For the rear loaders, we have different types of lifters available. The standard lifting device is the high-level lifter with a mounting frame according to the European norm. And you see here the low-level lifter. This is connected to the body, direct connected to the body, and it's integrated in the body. And you can use it in combination with a compactor to use it for collecting bulky waste and bin collection, curbside collection as well. The next type we're talking about is the side loader. There are different types of side loaders and lifting devices for side loaders available in Europe. We decided in our company to use the side loader with a rubber bracket here. So we can use the lifting device for any kinds of two-wheel bins, and it doesn't matter how it is placed at the curbside. When the collection area is optimally designed, you can lift up to 190 bins per hour with such a system. It is very easy to operate. If you want to lift four-wheel bins too, then you have to choose a side loader with a comp lifter. Such a lifting device causes more weight and reduces the payload and the loading speed. To empty the bin, you can tip the waste into the very simple compactor at the front, and it's located between the cab and the body. To empty the body, you have to open the back and tip it. The advantages of the side loader is the single driver operation for the curbside collection that makes it very effective and fast. You have a high payload of the lightweight because of the lightweight of the body. It is suitable for residual and bio-waste collection. It is a very effective and fast collection and is very easy in bin handling. The disadvantages are the body is very expensive. You have higher costs for maintenance because you have a lot of moving parts in the lifter. You have a lot of electronic devices to control the lifting device. And it is not suitable for collection of paper and packaging materials. On the front loader, front loaders are special trucks for pocket containers without wheels with a volume of 3.5 up to 4.5 cubic meters. According to the European standard, up to 6.5 cubic meters according to the standard of 2 German manufacturers. It is normally used to dispose commercial waste, but it's also used to collect all fractions at collection points where a curbside collection is not possible. You can empty the container by using the hydraulic forklift at the front. The lifting device tips the waste into the compactor and in the front of the body. Similar of the side loader, to empty the body, you have to open the bag and tip it. Excuse me. The advantages of these systems are it is suitable for waste containers up to from 1.1 up to 6.5 cubic meters. It is suitable for all fractions. It has a high compaction rate up to 5 to 1, and it has a very effective single driver operation. The disadvantages is the price. The body is very expensive, and you have a higher cost of maintenance because of the lots of moving parts in this kind of truck. That's all. Thank you for your attention.
Awesome. Christian, could you unmute yourself and then introduce yourself and start your presentation, please?
Yeah. Okay. 1 second. Google share my screen. Can you see my full screen?
Yeah, we can see it.
Okay. Welcome everyone.
The hide button there at the bottom.
Again?
No, actually, go ahead. Please go ahead.
Good. So welcome everybody. Also from my side, my name is Christian Rehmer. I'm the managing director of a company within the SSI Schäfer Group and responsible for all digital solutions of SSI Schäfer for the waste industry. So for those who do not know who Schäfer is, SSI Schäfer is the world's leading provider of products and systems for the intra-company material flows, but also, and that's my role, waste engineering. We have in total 70 companies worldwide and 10 or more than 10 production sites. We develop innovative concepts for our customers and the relevant industries. And our target is to shape the intralogistics, but also the processes in the waste management. So what I'm talking about today is bin and container systems. That's what my topic is. First of all, I think many of you already know which type of general container systems are available on the markets. I will not go into details with regard to swapping container systems. So which means I only focus on tipping systems where the container stays at the place where it's emptied. So in general, we can divide into 5 general groups of containers, starting with the very typical 2-wheel bins, which are mainly used for the curbside collection, so the house-to-house collection systems where the resident is putting the waste into the specific wheelie bins. Same system are the 4-wheel containers, which are available in steel or plastic. Also used for the house-to-house curbside collection, but also in some areas it makes sense to use these containers in bring systems, which means, for example, in satellite neighborhoods or living hoods. The 2-wheel bins are available in sizes from 60 to 360 liters, whereby the 4-wheel bins start at 660 liters up to 1.1 cubic meter. That's the average range of available containers. The next system, which is quite common in Europe or actually in Germany, are depot containers, which means these containers are placed within the living areas or on the streets, curbsides, and are used as bring systems for recycling materials, for example, for paper, glass, etc. The 4th container system is the front-loading system, which also fits to the last truck which Bernd has just shown to us. And these containers are mainly used for the industrial collection system, so industrial waste collection. The last and probably also the most complex system is underground systems, where you can only see a very small part of the entire container system overground, like an iceberg, and roughly 5 cubic meter containers are in the ground. And these systems are mainly used for brink systems in high density areas where we have only small space for waste containers to be placed on the surface. So the question is, which system is the right one to start a sustainable waste collection in my area? For this, I would like to go into some sideways, having a look at the people living in cities. So some mega trends, which means in the 1980s, we had 39% of the world population living in cities. 2012, it was already 51%, and it's expected that 69% of the world population in 2050 is living in cities. So especially mega cities is a big topic, where we have, for example, in 2020, more than 100 cities in China with a population of less than 1 million. This has an increase on, or this has an impact on the increasing income as well. So the change in waste composition. So the waste composition will change in the next years, which means we have more waste, more packaging material, but less biological waste. So we have more material streams. This is causing a couple of facts, or resulting in a couple of facts. We have increasing demand for resources. We have the demand that material recycling is absolutely necessary. Material recycling at the end reduces CO2 emissions, and we have to be aware that waste to energy is only a one-time use of resources. So which means waste to energy, not waste to energy. And this is something what we have managed in Germany, for example, quite well. So we have decoupled the raw material consumption from the welfare. Which means we have, on the one hand, we have the welfare, which is going up in emerging markets, but the environmental impact has to go down at the same time. What have we achieved in Germany? Having a look at the waste composition in Germany over the last years. 1990, we have 87% of really refuse and rest waste, which has been burned or dumped into dump sites, and only 13% of recycling material. 2004, we already cut it on the half, the rest or refuse materials. At the same time, we raised the recycling quotes to 58%. And in 2015, we had only 37% of material which has been burned or which was rest material, and 63% of all materials, of all waste, has been recycled in Germany. So this results in a couple of solutions for bin systems. I will show you two systems today. On the one hand, the 2-bin system, but also the 3-bin system, talking about the curbside collection. For example, if you're talking about the 2-bin system, you have two ways for the material. The dry waste bin, which you first of all sort and you get recyclables out. And the rest is something which you burn, and after the end or after burning, you dump, for example, ashes. For the wet waste material, which is coming from the 2nd bin, you're using processes like fermentation or composting. You get biogas and energy, but also compost for the farming industry. The 3-bin system is a little bit more complex, which means you have only recyclables in the dry bin. Same process like before. You have only rest and refuse waste in the 2nd bin, and you have wet waste into the 3rd bin, which you can process at the end in the same ways like in the two-bin system. From our perspective, the separation at source will decline because the technical developments for the sorting industries, etc., that good already that only a 2- or 3-bin system is foreseen for the future. Coming to some surrounding systems, bin systems, after you have implemented bin systems, are not only lonely. You can also make a non-intelligent bin or container system intelligent by various technologies or solutions. For example, the RFID technology enables to identify single containers and bins for service verification or even billing processes. And RFID technology can be the basis for route optimization. Smart sensors, which goes, for example, into the depot containers, like fill level sensors, enables towards a service on demand-based collection. And this helps to reduce inefficient collection processes. The software and software platforms are the planning and management of waste operations through automated or semi-automated processes. This helps you at the end to enable or to live an efficient collection, and to control everything. You need the telematics on board, which is giving you the performance data of the trucks. And for these trucks or telematics, you also integrate the RFID and or weighing solutions. Just to give you an example how an RFID could look like, this is it doesn't work. No, it doesn't work. Sorry, I have a video which is, I had planned to show you a video, but it doesn't work obviously. So I just will switch this slide, which is only showing RFID. So how could a target scenario look like for bin and container systems? Separating everything. So you have the in-field where you have depot or underground containers for recycling materials, for example, like glass, which are enabled with smart technologies like fill level sensors to operate efficiently. You have citizens and the industry, which have bins with RFID and clear identification of collections. And in the middle, you have the operations software solutions for route planning and order management. But at the end, and this is very important, is you also have the city involved on transparency and on recycling. They have clear information on waste collection activities. And at the end, this is giving a whole picture of collection systems with containers. How does it work? How do I introduce sustainable container systems in 3 phases? First of all, from our perspective, you should do a basic analytics. How many people are living there in the region you are targeting? What is the geography? What is the living density? To understand the basics of how many people and streets, cities, etc. have to be addressed. After this, you should do, from our perspective, a definition of which materials shall be separated. It is the waste stream definition. How do I want to split my entire waste up? And at the end, they can start with a cost and revenue stream calculation of different scenarios and also with different technologies, depending on what you want to achieve. And this is really a case-to-case solution. There's no global solution which container systems or bin systems can be used. It depends on what shall be achieved and which level of separation or segregation are you in already. So this is my part for the presentation. Thank you to everybody, and I hand over to Jürgen.
Hey, Jürgen, please unmute yourself and you can start your presentation.
Okay, thank you very much. Thank you very much, Bernd and Christian. Yes, my name is Jürgen Jacobi. let me just share my screen. There we go. Should be up and running now. I hope you can see it.
Yeah.
I work for a company called NVAC, which name you see here. We are located in Stockholm, in Sweden, so we're a Swedish company, and we're also in the business of waste collection systems. However, our approach is slightly different to the two presentations you just have seen, because our product is based on an underground waste transport system, and I'll walk you through that technology in my slides. Just give you some idea of who we are. We are quite unknown company, but we are actually world leader in these automated waste collection systems. We have offices all over the world. Main markets are, of course, the Asian markets as well as the Middle East, where a lot of city developments are happening. And I fully agree with what Christian has said. The increase of populations in cities that will happen in the future will, of course, pose enormous demands on the waste collection systems in those areas. And we believe that our technology is quite attractive for certain areas. I don't want to say for everything, because there is no one solution that solves everything, but we do have an idea of where our product can make quite a big difference. Well, our strategic mission is we want to bring value to our customers, and you do that by obviously delivering systems that work efficiently and cost effectively, and where we see that every participating partner is also getting a benefit from it. That benefit may be a money-wise issue, it may be increased performance, it may be increased living quality, and we think that our technology fits quite well into these criteria that we see here. Now, what is it all about? Basically, is our idea is that users, and in this picture that you see here, it's an example from a residential area, is taking their waste to do these so-called waste inlets that you see with my mouse, that you see here, which is basically a tube that sticks out of the ground. And underneath this tube, you have a certain collection volume where you can put your waste in. And by sensor technology, we know how much waste is in these tubes that you see here. And whenever those are overfull, or whenever before they get overfilled, we empty those by opening a valve at the bottom. The waste fraction falls into this large pipe in the ground. And then by evacuating this pipe system, we create a vacuum. Then we open this hatch here, and you get a gust of air, and this gust of air transports the waste into a centralized terminal. That terminal is essentially just a big container where all the waste is collected. And the distance between those inlets and the terminal can be up to 3 kilometers. So it is quite far. What we see here is one of the main advantages for especially tight residential areas is that you increase the housing quality and living quality for the people in those areas, because you remove the trucks from the immediate houses and have the truck collection more in one centralized area. So we reduce traffic, we reduce noise, there's less impact on the living quality, and certainly a lower risk of accidents happening on the streets. Show you a couple of pictures of how these inlets may look like. We have all kinds of different architectural designs. Those are always depending on what our clients, our customers would want to have in their city picture. This big one here you can see on the right-hand side is a relatively new design we have, which we use for small carton and packaging material. I'm sure you all know that due to Amazon and Zalando and these type of online shipping companies, the amount of packaging material that has been found in the waste streams during the last 2 years has increased dramatically. And carton boxes are very voluminous, they don't weigh much, but it's a very good resource to be reused again. So we want to make sure that we can offer a technology as well to collect carton and small carton packaging boxes with our system. You have these other types of cylinder type of systems, or square ones that look like pretty much a normal waste bin that you would see in any city. The real technology of these is actually underground, and you don't see that. One of the applications that we have with this system is also a hospital area, where you of course have certain types of waste streams in those systems. And it's the same application here. We have inlets in the walls or in the hallways of these hospital floors, and from there we suck the waste using the exactly same vacuum technology to a centralized terminal from where the waste can be collected and treated separately, depending on what fraction you have. What we see as an advantage for hospitals with the NVAC system is that basically without the NVAC system, you need on every floor of a hospital, you would need space for storing waste, for intermediate storage. Now that storage room is much better used as a patient room or operation rooms or whatever rooms you need in your hospital. So there's more room available for care. You can actually have a wider corridor. So you would, you need a wider corridor with a waste by bin system. Sorry about that. You also need to transport then from these intermediate storages. The waste has to go down normally into the basement somehow, which would mean you would have to be transporting waste and possibly contaminated material in an elevator that may also be used for other purposes. So you increase a cross-contamination risk. So by removing the waste from the public area, so to say, and going it through a vacuum system, which is a sealed pipe, you reduce this cross-contamination risk quite dramatically. And again, you increase I wouldn't say the living quality of the hospital, but certainly the working quality of the staff in the hospital by getting the waste out of it as soon as possible. And we think this is a very good application for this system. Now, this is actually a picture you see on the right-hand side, which was taken in hospital, and it's certainly something you don't want to see. Bagged waste lying on the floor in a corner somewhere. And I hope you can see it on the screen. There's actually this waste bag here is punctured, and there is some blood-contaminated material has fallen out onto the floor. Sorry. You certainly don't want to see that as well. Another aspect which is quite nasty and not very nice to know about is pest control in hospitals, of course. Again, it's an area, a hospital is an area with a high infectious risk where a lot of organic material is available, so to say, which attracts pests, of course. And again, by reducing the amount of organic material that is available through an NVAC system, you also reduce the access to that material by rats and similar pests. Another application area we have for our system are large kitchens. That may very well be a kitchen of a big hospital, or maybe a centralized kitchen in an airport system, something like this, where you can have a set of various food waste inlets distributed all over the large kitchen, and from where it would be then sucked away into a centralized terminal. So we combine the available waste materials into one spot, into one terminal, from where it can be transported away, which saves your workforce in transporting waste from A to B and gives you a more hygienic and more cleaner working environment. We have one demonstration project running at the moment, which you call the Smart Waste Collection, the Grow Smarter project. It is basically one waste inlet that is above the ground, and for this inlet you can use multiple fractions. So these multiple fractions are differentiated by being put into several colored plastic bags. You can have all kinds of colors for all kinds of fraction you want. All go into this one inlet. They fall onto a weighing system, and the color of the bag is registered as well. So you get quite a lot of nice data, how much waste fraction has been put into this inlet from how many households. And I will show you a short video. I hope this works. Yeah, it seems to be working here. I will not torture you too long with this one. The idea is that you take source separation of different waste fractions into the households, onto people's kitchen, where you have different color bags for different materials. Once those bags are full, you have an RFID tag. You go to this inlet and you register yourself with the RFID. The machine or the inlet itself scans the color of the fraction, so we know what material is in there. It is weight. So this would give you even the possibility to have a financing system based on the weight per household. It is sucked into a terminal from where the waste fractions then are picked up by a truck and can be shipped on for further processing. Excuse me. In this case, as you can see here in the video, which I'll come to in the next few slides, it goes to a centralized sorting facility where that waste stream is then separated according to the color of the bag. And by ensuring that we have good education and good participation of our different households, we can make sure that we get a very pure waste fraction of the respective waste material. So in the bags where you should only have plastic packaging, we want, of course, to reduce the amount of organic waste in those bags. So with this system, we can combine source operating of waste together with an underground system and give an added value to households, but also to people who live in that area. And this brings me now to the next slide that I want to show you, which is this one, is the second product of our company, which is basically bag and bin, as you would call it in English. The whole idea is very similar to the Grow Smarter project, that within your kitchen or in your household, you separate the different waste fractions into different colored bags, all go into one bin. They are picked up by your garbage truck, just as it is today. It goes into a centralized sorting facility where the bags are then sorted by color, and you end up in containers like this that are ready for processing further on. And I'll show you again, short video here, how these plants actually look like. Now, this is a two-line system where you see blue bags for plastic packaging, you see green bags that contain food waste, and all other bags, as well as loose items, that's the trash, that from this plant will go to incineration. And these stations here that you can see are our pusher units, where we have a very simple pedal that basically kicks off the bag from the conveyor belt and then sorts out, in this case, what you can see back here, sorts out the blue bags for plastic recycling in this case. Oops, there we go. What we believe with this technology, with the bag and bin system, is we obviously reduce the amount of bins that you need, and by doing that, we also believe that we can reduce quite heavily the amount of trucks that need to be driving around in your area. So by using everything in one bin and then sorting it at a centralized station, you get a technology that is quite feasible to increase your source separation, to increase the possibility for recycling. It gives you good raw material without increasing the waste collection costs. We have seen this in more than 20 installations that we have in Scandinavia, that this highly automated technology gives you a low operational cost. We've also seen that it is quite easy to implement for new customers. You don't need to change the consumer behavior that much. What we need to tell people is that you need to separate the waste in your kitchen and put it into different bags that can be of different materials. But it's also technology that can grow with time. One of our clients just a year ago started sorting textile as a 7th fraction. And the only thing they needed to do was a little bit of reprogramming to the units to be able to see another color of the bags. And this, I believe, is my very last slide. I'd like to thank you for your attention, everybody, and I give the word back to you, Ranjit. And I'll stop sharing my screen here now.
All right. Thanks, Jürgen. Thanks, Bernd and Christian. Well, we have some questions from our audience. And friends, if you have any questions, see the live chat window. It's right below the video stream. Use that to ask any questions that you have. We've already had a bunch of questions. Jürgen, since you just finished, let me start with you. And the first question for you is from Kim. She's asking, so she's asking, how does the NVAC system compare to traditional waste collection systems when it comes to energy consumption and energy consumption and environmental indicators? Well,
thanks for the question, Kim. That's actually a very good point, and we get that question quite often. We obviously need energy, electric energy, for the vacuum system to put the entire piping system in vacuum. And basically, we say per ton of waste, you need about 50 to 100 kilowatt to vacuumize the system. Now, putting that into relation of the fuel consumption of your truck, of the trucks you would need, that is very difficult to answer because it is so dependent on the routing of your truck. So it's hard to say, well, this one is better than this one. What we see, however, when we do an analysis of an area where we would like this NVAC system, is that the amount of kilometers that have to be driven by a truck to empty the bins, that is massively reduced. And we're talking about a reduction of 80 to 90%. So I would dare to say that the energy is, or the win of energy is quite good for the NVAC system, because you would use electrical energy rather than a lot of diesel fuel for your trucks.
Jürgen, while you're at it, we have one more question. How does it compare to others when it comes to maintenance costs? That's a question from Katerina.
The maintenance cost of the pipes is very, very low. I mean, we build them obviously such that they last forever. And when I say last forever, I'm talking about 40 years of lifetime. The containers itself, they're steel containers. There's not much in there as well. If you do your proper maintenance of your venting system, your fan system, and so on, then you can keep the operating costs quite low, I would say. Again, comparing it to a more conventional truck-based pickup system, that is very, very difficult to answer because there's such a variety of different systems. One of our NVAC systems we have in the very north of Norway, and the main driver for that client was because they need to empty bins in a hilly area, and during wintertime they just cannot get up there with their trucks. So they had to have something else to pick up the waste. And then the NVAC system came in quite handy.
All right. And now the next question is to Christian. Christian, could you talk a little bit about the markets that you're working in and where different kinds of your products are being used right now, products and services are being used?
So our products are used worldwide, actually. So our head markets or main markets for sure are the European markets, so UK, France, Netherlands, Benelux. But also we have many products in Southeast Asia, and we have an own production facility in the US. So the US is probably, after Central Europe, our second largest market, and that's true on the one hand for the container systems, but also for the digital solutions. So those are operated worldwide in different conditions.
All right. And when you mean digital solutions, do you also offer software for waste collection?
Yeah, we do.
Okay. Then there's a question from Luis, who's asking, can you recommend a good software for waste collection systems? So, of course, it's yours. Can you recommend? Well, yeah, that was the question, so I'll let you respond to that.
Okay. Yes, so for sure. Yeah, we as SSA Schaefer also develop and customize software solutions for the waste operations industry, and this is our software is available worldwide as well.
All right, great. So Bernd, this is a question for you. You can unmute yourself before you respond to it. And the question is, as a decision maker, you know, who's maintaining such large operations in Germany, how do you decide when to, you know, make improvements, or like what kind of factors lead you to, you know, taking certain decisions? And as you're responding to that, we have some participants from the Middle East, from United Arab Emirates and Saudi Arabia. You know, these are both economies where they're trying to improve collection systems at this point, and they have, you know, even though they have enough resources, again, spending a lot of money is never, you know, you know, you can't spend a lot of money just because, you know, you have, so it's always tight. So could you respond to, you know, to that question, keeping in mind economies like, you know, in the Middle East, which are trying to take a decision and improve their systems?
Okay. Yeah, when you want to buy a collection system, truck-based collection system, and you don't want to spend so much money, I think you have to decide to buy a normal standard wheel loader. You can collect all fractions with it, as I mentioned, and the price is not so high as for the other system I showed. So would prefer under this circumstances a standard rear loader with a compactor at the rear.
Okay, and how about systems when it comes to digital solutions or NVAC-like systems? Do you have any recommendations on that? How they should think about it?
I don't understand the question, I think.
As a decision maker, when you come across solutions like digital solutions or like Christian's offering or NVAC that Jürgen's offering, so how should these decision makers think about these solutions?
About the NVAC system?
NVAC, Jürgen's NVAC system.
Yeah, okay. This is, I think, a problem of the country you are in, and you have to make in which you have to make the decision. In Germany, we have a legal problem with the vacuum system. It's very difficult to install it because we, as a waste management company, can't do this investment. And in the Asian region, it's better to use it. I think we discussed it in our working group. It's not. I think it's not possible at the moment to install such a system in Germany. So we decided to use our normally truck-based systems, collection systems.
Okay, all right. And
if I may jump in there, Ranjit, just as an example, and I fully agree with what Bernd has been saying. I would like to mention here that the city or country of Singapore has about 1 year ago, they passed a law stating that housing residential areas with more than 500 units of houses or flats have to have some kind of underground waste transport system. So that is not something where it goes directly to NVAC because we do have competitors, but it illustrates very much like you said, Bernd, that the boundary conditions for one system or for another system are depending on very many different aspects, like the legal system and who owns the waste, but also what is the political point of view? What does the legal decision makers want to install for a system? In Singapore, they may have otherwise opted for that you must have a certain amount of bins, of a certain size of bins, but they opted for an underground system. So that is indeed a very difficult question to answer.
Right. We are definitely getting a lot more questions for you, Jürgen. One more question from Katerina is, what kind of challenges did you encounter when you were implementing your pilot system or in the hilly area that you mentioned earlier? Could you talk about that?
I would say one of the major challenges that we have, it's again for our system, it's also, of course, comes down to cost. What does it cost? And one issue that we see quite often is that with an NVAC type of system, you need to take an investment heads up. So you pay for the pipes, you need to dig the pipes into the ground, build your terminals and all the inlets, etc., which means you have a big payoff initially. You save quite a lot of money on the operational expenditure because you save trucks and you save staff. On the other hand, if you look into a city's budget, there are two different budgets. One is for the investments and one is for the operational cost. And those two budget owners often don't speak to each other. So it comes down to who has to pay for what. This is one challenge that we need to overcome. And we have succeeded because otherwise we would not be in the market anymore.
Right.
The other more practical issue I would say is it also, even though it's a system that is nicely or widely accepted and people like it, we do customer service and it's generally well accepted. We have to make sure that it's not misused. So it's really a system for trash and not for bulky waste. And you wouldn't believe what type of stuff we find in our inlets once in a while. Everything from a skateboard to a chair to a carpet is put in there. And this is, of course, making quite a big problem for the other users that you have living in an area. So there is also the educational aspect to make sure that people know how to use the systems.
Right. And Christian, there's a question for you. With the advancement in sorting technologies, how does using bags compare to using bins for door-to-door collection systems? In that you can talk about economics, ease of use, increasing participation. This question is from Mohammed from Saudi Arabia. So he's also asking about communal bins also when you're talking about this. So, yeah.
So at the end, it depends a little bit of where you're living and which region you are acting. I think the more easier way to implement an initial system for sure is the truck and bin based system, because you do not have to have a lot of constructions like Jürgen was saying that that is needed for the NVAC system for sure. It depends on where you're living. So if you have a quite dense area like Singapore or the hilly Norway project which Jürgen was describing, then the NVAC system might make sense. But as soon as you're having enough space, I think probably the bin-based system is still the major way to go. Not only that I'm working for a bin manufacturer, but I think it's also I think it's an easier way to start with a sustainable and reliable collection. We are working in the Middle East as well for some projects. So I know that they started introducing bin-based systems to overcome waste collection in skips, for example. So I've seen regions where still skips are placed on the streets and people are throwing in everything, and they wanted to overcome this situation by just placing bins in front of the households or putting smaller bin sizes and enabling a regular collection. And supported by digital transparency. I think that's a major fact. You need transparency for the collection, who's doing what and which waste amounts are in the streets. And after this, you can still define where to use still to use a bin-based system, or where you want to change to a NVAC system. I think a vacuum system is always good if you have a high or premium living areas with a lot of demand for nice surfaces,
Makes sense. So Jürgen, we have one more question for you, but before that, let me remind everyone that these are the last few questions, last few minutes. So if you have any questions, please use the live chat window below the video stream to ask your questions or put any comments that you have. Yeah, so Jürgen, the question is, in the NVAC system, what happens when the bags are accidentally opened during the transportation? Is this waste collected? Does it affect the pipes? Or does it increase maintenance costs? Or are there any measures to clean the pipes? This question is from Pedro from Spain.
Mm-hmm. It does happen that the bags break during transport. That's just the nature of the bags. I would not say they damage the pipes. Of course, you do damage the inner surface of the pipes, but not to an extent that the lifetime of those pipes is significantly reduced, I would say that. And over the years, we have learned enough to know how to dimension our piping system in order to be able to cope with that. And keep in mind, most waste is, compared to steel, very, very soft. So the most critical issue is glass, basically. So we can transport glass in those systems as well, but that means we need to put a little bit more focus on the type of bag that we're using. The bags that do break when they go into the terminal, they are obviously harder to recycle and to sort out if you think of the different colors. You may have seen from one of the slides that I showed you where you have 3 different inlets, but you also have 3 different containers. So if we have a system like this, we always know we only empty the green inlets, which would be for organics and for food waste, and that waste only goes into the container for food waste. And there it doesn't really matter if the bag is intact or not, because the entire content of that container would then go to a biogas facility, for instance. If it is plastic packaging, it will go to a plastic recycler as a whole. So it doesn't really matter if the bags are intact or not. When it comes to the Grow Smarter, there is more focus. And now this is a pilot project that we just started about a year ago. And there we're using more solid bags. They're a little bit thicker, so they last a lot better, to be honest. But there's certainly a development that we need to monitor and see over time. But to answer your question, I wouldn't say that bag breakage inside the pipe causes an operational hazard. I hope there was an answer to the question.
No, yeah, that's good. We have one more question, and before that, Mohammed asks, will the presentations be shared? Yes, we'll get all the presentations from the speakers, and we'll put it on the ISWA website and also on BWasteWise website, so you'll have access to them, Mohammed. And before going to the last question to Jürgen, I'll ask a question from Bernd and then come to Jürgen. So the question for you, Jürgen, is from Pedro again, from Spain. He's asking, could you tell the approximate amount in dollars per ton for comparing investments and operation for vacuum and traditional waste collection systems? But before that, you respond to that, let me get to Bernd. And Bernd, so in your region, what are the waste collection system improvements that you're planning in the next few years, or maybe in the next 10 years? Are you planning anything for improvements?
Yes, we like to install the collection of bio-waste in Hamburg, and we have to increase it, and we have to, we are planning to build a new waste to energy plant for bio-waste in the northwest of Hamburg. This will be one of our biggest challenges in the next year.
Okay, and so it's an anaerobic digestion plant, is it?
Yes, we will have a big sorting plant for household waste. We make a segregation of bio-waste out of the household waste. And we will have a waste to energy plant where we get biogas and composting plant.
Okay, all right, great, thank you. So Jürgen, back to you. The question about dollars per ton.
I'm afraid I cannot really answer this in comparison to a standard collection, because every system we have is really dependent on the amount of users that are connected to it, the length of the pipes, the number of inlets, and how the street looks like and where the truck would be driving. So we have really to make a tailor-made analysis for each single case, and whatever number I would give here would be wrong, to be honest, and would give you the wrong picture. So I'm sorry, I cannot really give you a number there. It just wouldn't make sense.
Is it generally higher or lower than the traditional costs in general, majority of the cases?
I would say it's lower, because you do save a lot of the operational expenditure, and you get a higher purity of the waste fraction.
All right, so the CapEx will be paid back with the IRR.
Yes. Yeah.
All right, great. Good to know that. So with that, friends, thank you so much for joining us. We've had a really lively discussion, and with that, we are at the end of another webinar with ISWA and BWasteWise. And please follow both ISWA and BWasteWise to know when the next webinar is and how you could participate in that. And we will share all the presentations with you. And yeah, that's it. So thank you so much. Have a good day, good evening, and good night. Thanks, Bernd, Christian, and Jürgen for joining us.
Thank you very much, everybody.
Bye. Bye.
Great.